Hey, welcome back, you crazy cats. Today we're going to learn how to calculate power and how to calculate efficiency for power. Power is the rate at which work is done. Power is work over time. Units is watts. So real simply put here, our first practice problem, how much power must a motor have to operate a pump that raises 150 kilograms of water every minute a distance of 12 meters? Well, as we said here, power equals, let's see if I got my pen, power equals work over time. Well, every minute. So my time here is equal to 60 seconds. Work equals force times distance. In this case, the force is going to be the weight. All right, as I'm thinking here, we've got the weight of the water. So I'm going to use mg. The mass is 1,500 kilograms times 9.8. So that weight, or the force in this case, is going to be equal to now I'm pausing here before I give you the answer, giving you a chance to type it into your calculator, but that'd be 14,700 newtons. The distance is right here, 12 meters. So my power, my work, is going to be 14,700 times the distance of 12 all over 60, because it's 60 seconds. And the power turns out to be 2,940 watts. So what power is used by a 30 kilogram child who runs upstairs, going a vertical distance of 25 meters in 30 seconds? Well, we're going to do this the exact same way. Force in this case is going to be the weight. So I have the mass of the child times gravity, which is 30 times 9.8. Here's our distance. Here's our time. So the power equals work over time, which is going to be, I haven't calculated anything out yet. I advise you guys to pause it. So we find the work by, or the force, by taking 30 times 9.8, which turns out to be 294 newtons. So that's my force, 294 times the distance of 25, all over time of 30 seconds. So I'm pausing here again to give you guys a chance to work this out, and you should get an answer of a power that's equal to 245 watts. Okay, let's talk about efficiency. Mechanical efficiency is the work output over the energy input. The efficiency of any real system is always less than 100%, and that is due to friction. Alright, that is due to friction. Work, if you guys, it's been a while, a couple days, over the weekend possibly, work is energy. Some of you I know have forgotten that already. So it says work output over energy input, but it's really the energy output as well. I mean, it's still, they're both going to be measured in joules. All right, so it's joules over joules. So the reason I bring that up is I want you to realize that there's not an what's the word for energy or for efficiency label. There's not a label for efficiency. Sorry, it took me a little bit there. Okay. Some typical efficiencies of some machines: compressor about 85%, electric motor 70 to 95%. Automobile, hybrid cars increase fuel efficiency by 25%, but typical automobiles only 20% efficient. Your human muscle, steam locomotive. All right. So what did you learn? All right. In your notes, we're just about done with the notes. What is power? All right. And what can we do to make power greater? All right, what do we have to decrease if we want to increase the power? Or what do we have to decrease if we want to increase the efficiency? So there's really two separate questions there. Hey, I'll catch you guys on the flip side.